2 times 0 plus 1. Zero squared is what?
0.
2 times 0 is what?
0.
And then you have plus 1. So you have 0 plus 0 plus 1. So y equals 1.
Yay.
So your y is 1. And what does your y-intercept equal? 0, 1. Where did that come from? Your y-intercept is a point on the graph. So you need an x and a y value. How do we know that my x was 0? Because we plugged in 0 for x. And then you got your y was 1. So what was our vertex? That way I can go ahead and put it up here. It was
Negative 1 comes to 0.
negative 1, 0.
Yeah.
Alright, so the third step was to graph that equation. Okay? It's to graph it. I'm not sure how we're going to do this because I need to graph over there.
Or you could just grab from the side.
We'll have to do that, I guess. Alright, so we're going to graph our points. So the first point that you're always going to graph is going to be your vertex. And our vertex is negative 1, 0. Does everyone remember how to plot a point on a graph?
Yes.
So we know Kaysan does.
Yeah.
Everybody remember? Okay. So you're going to plot your x first, then you're going to plot your y. So I'm going to look at my x-axis, and I'm going to go negative 1. So we go to the left 1. Then our y is 0. So you go along your y, you go 0, which stays right on that x-axis. And you plot your point. You are then going to immediately put a dotted line through that vertex. Why? Because that is your axis of symmetry. And it always goes straight down through your vertex. The next point you're going to graph is your y-intercept. Your y-intercept is 0, 1. So on our x-axis, we're going to go 0, which is going to keep us right here. And for our y, we're going to go up 1 so that we're on the positive 1 position. For a parabola, so the graph of a quadratic equation, you must have at least 3 points in order to graph. At least 3 points. So right now, how many points do we have on the graph?
2.
2. So how are we going to find our third point? We're going to use our axis of symmetry in order to figure out what our third point is. When you think symmetry, what do you think of? Symmetric. So what does that mean?
Like
Even on both sides, right? It looks the same on both sides. So I think of a reflection. So if I look in the mirror, then I can get it's the same thing on both sides. I look exactly the same in the mirror as I do right now. It's symmetrical on both sides. So what I see on the right-hand side has to be exactly the same as the left. So since there's a point right here, 1 away from our axis of symmetry, that means that you need to make the same thing happen on the left side. So it's going to be 1 away just on the left-hand side. Same height and everything else. That way, if this was a piece of paper, and we were to take it and fold it on our axis of symmetry, the points would be sitting right on top of each other. Does that make sense? Okay. So then, once you have 3 points, you can go ahead and connect your dots. So we're going to take this one and go up. Take this one and go up.
cool.
So was your A positive or negative for this example? Positive, because it was a positive 1. Is this a happy face?
Yeah.
Alright, then we graphed it right. Don't make the common mistake of using the y-axis as your axis of symmetry. A lot of people will make that mistake because they forget to go ahead and put that imaginary dotted line. But if you go back and you look at what your A is, a lot of times it will end up working out for you, because when you look at it, you could have the happy face But when you graph it, you use the y-axis as your line of symmetry, and it'll end up being a frowny face, so you'll know that you did something wrong if you look back at your A and see what it is. Okay? Does everybody understand how I graph with points? Good to go? Alright, so let's go over another example. This is still going to go in the second part. It's still going to be in the second column.
Okay.
Why is it not erasing at all? Alright, so that's just my graph, don't worry about that. Now we have y equals 2x squared plus 4x. Y equals 2x squared plus 4x.
Hey, that was
Huh? This is still the second column. Yes, sir.
What if you don't have a way for a second column?
Then attach a piece of paper because we're going to be using all of the columns. Okay. So once again, we're going to find our A, our B, and our C. Looking at this equation, what is your A? 2, because your A is always attached to your x squared. So what is our B?
4.
Positive 4, because your B is always the number attached to your x. And your C is what? 0. Your C is always the number that's by itself, and since it doesn't have a number that's by itself, it's like saying plus 0. So your C is 0. Now we're going to look for our vertex. You look for the x value of your vertex first. So we're going to do x equals negative b over 2a. Once again, I'm going to do it on the left-hand side because I don't have room to write over here, so it's not sloppy. But y'all are writing it in the second column. So we have x equals negative b over 2a. So you're going to plug in your values for a and b into this equation. Make sure you put parentheses around it because they are important. So we have negative 4 over 2 times our a is 2. Now it's time to simplify. The top is going to be negative 4. The bottom is 2 times 2, so what is 2 times 2? 4. And what is negative 4 divided by 4? Negative 1. So your x value is negative 1. But your vertex is a point on the graph, so it's a coordinate. You have to have an x and a y. How are we going to find out the y value? We're going to plug in the value that we got for x back into our original equation, and that will give us what our y is. So I'm going to do that over here. So your original equation is y equals 2x squared plus 4x. Everywhere I see an x value, I'm going to take and plug in x equals negative 1. So I have y equals 2 parentheses. The parentheses are very important. Negative 1, close the parentheses, squared, plus 4 times negative 1. And then you simplify. Use order of operations. So we're going to do exponents first. What's negative 1 squared? Negative 1. What?
Wait,
1.
Yes.
Negative 1 squared is like saying negative 1 times negative 1. So
1.
positive 1.
Yeah.
So 2 times 1.
So 2 times 1 plus, what's 4 times negative 1?
Negative 4.
So I'm just going to put minus 4. 2 times 1 is 2 minus 4. 2 minus 4 is negative 2. So that's what your y value is. So your vertex is going to always be x, y. So our x value is negative 1, and our y value is negative 2. Everybody good on that?
Yeah.
Perfect.
Don't erase it.
Don't erase it. Hold it on. The next thing we're gonna do is we're gonna look for our y-intercept. So how do you find your y-intercept? We're gonna plug in 0 for our x to find out what our y-intercept is. So your equation is y equals 2x squared plus 4x. So everywhere you see an x, we're gonna plug in a 0. So now we have y equals 2 parentheses 0 squared plus 4 times 0, which gives you y equals 0 plus 0, so y equals 0. So what is your y-intercept?
0.
Remember that your y-intercept has to be a point. It's a coordinate on the graph.
0,
0, 0. Where did we get 0, 0 from? We plugged in a 0 for our x, so we know that our x value had to be 0, and once we plugged that in, we got y equals 0. So 0, 0 is your y-intercept. Do you want to know a shortcut for y-intercept? Y-intercept will always be 0c. Always. Because no matter what you multiply by 0, what are you going to get as your answer?
0.
Perfect. So if we plug in a 0 here, what's it going to go to? It's going to go to 0. If we plug in a 0, 4 times 0, it's going to give you 0. No matter what you would have multiplied that by, since you're multiplying it by a 0, the only thing you're ever going to be left with in that equation is whatever your leftover number is by itself at the end. So it's always going to be 0c. Okay? Any questions on that part?
No.
Perfect, fine and dandy. Alright, so now let's graph.
Whoa.
Same process, we always graph our vertex first, and our vertex was -1, -2. So I'm going to graph -1, so I'm going to go on my x-axis and go to the left 1 so that I'm on the -1 position, and go down 2, so 1, 2, and plot my point. Then immediately after graphing my graphing my vertex, do your imaginary vertical line straight through your vertex. Make your axis of symmetry. Now we're going to graph our y-intercept, which is 0, 0, which is right on your origin.
Don't still gotta be a third
We
point.
still have to have a third point, so how do you find it?
It's like reflection.
You use your line of symmetry, so we need to make it symmetrical on both sides. I am 1 away from my line of symmetry, so I need to be 1 away in the opposite direction. And then you plot your point. Does everybody see that?
Yeah.
Okay. Now that you have 3 points, you can take them and connect your dots, and you have graphed your parabola. You good? Okay. So that was standard form. So now we're going to figure out how to graph it if it's in vertex form. So we're going to skip the third column, and we're going to go right over to our fourth column so that we can learn about the characteristics of a vertex form equation. So this is how to graph vertex form equations. In order to be in vertex form, you have to be in y equals parentheses x minus h, close parentheses squared, plus k. Just a little extra tidbit to help you kind of understand vertex form. H stands for horizontal, and K stands for vertical. Don't ask me why they didn't use a V, I don't know. I don't make the rules, I just know them. H is horizontal and K is vertical.
Is there negative?
What's up?
Is there negative A or positive A?
It's y equals A, parentheses x minus h, close parentheses squared, plus k.
Alright.
So if you have a problem that is in this form, you're gonna first look for your vertex. Your vertex is always gonna be HK, okay? But you cannot forget that your original equation is x minus h, so it means that your h is actually gonna look like it flips. So if it's x minus 5, your h is 5. If your h is positive 5, then it's actually going to be your h is 5. So if it's x plus 5, then your h is negative 5. If it's x minus 5, it's going to be h is 5. So it looks like it's going to split sign. You're going to see when we talk about an example what I mean. So you're going to plot the vertex on your graph. And then you're going to choose points on either side of the vertex using a table. I'm actually going to have you guys plug it into your calculator, so if once you write that down, please jump up, switch out your phone to calculator, because you need to get practice doing that.